Hello everyone, this is the video lecture for Calculus 1, section 6.3, shell method. Let me give you the formula. So volume is equal to 2 pi integral of x times f of x dx, and this is going to revolve about the y-axis. Okay, again, this is a duplicate of my Calculus 2 lectures, so you can go there and get another version of this, I suppose. So we now have the ability to revolve around the y-axis. That's actually really what we're going to be doing. But I'm going to just make a quick comparison between the two methods here. So we got disk, I don't know, washer, I never call it that, disk method, and we got shell method. And so the volume here is pi integral of, let's just be honest here, it's top squared minus bottom squared dx. And that's about the x-axis. And then my shell method is the volume is 2 pi integral of x times, to be honest, top minus bottom dx, and this is about the y-axis. So just as a quick review here, I guess you can say I have my top, I have my bottom, and let's say I'm just revolving it here about the x-axis. That would be my area, and so what would be the shape would be something like a barrel or something, and your axis would go right through the center, technically there and out there. Okay, let's do something like a quick picture over here. Let's say I've got a line, and let's put this guy down here as my bottom. So I've got a top, I've got a bottom, I've got this area right here, and I want to go around the y-axis. And so what would this end up looking like is something kind of like a dog bowl. Not really. It would be maybe some weird, oh, I know, it's an ice cream cone holder. Yeah. So, and there's like a tiny little hole out the center there. There you go. So on the inside, it looks like a cone holder, basically. Cool. So there is the different ways of doing it. You got your x-axis, you got your y-axis, you got tops and bottoms and all that stuff. This is it right here. Take a picture. All right. 63001. So I've got y equals 7x, x minus 1 all squared, and it says about the y-axis, and we're going from 0 to 1. All right, so volume is, you know what, let's draw a picture. This is a cubic, I guess, and this at 1 is going to be a touch point, so it's going to do something kind of like this here. And we're going 0 to 1, which just means this little area right there. And we're revolving it around the y-axis. And so what you're ending up with, and this is kind of a little weird picture, it looks like a hump that's just like a donut, I guess. It's like a donut hump. Actually, it's going to extend down to the center here. There. And so you got all this on the outside, but then you also got this hump on the inside. There you go. It's like a half of a donut, kind of. So, yay! There's your axis of rotation. The bottom half's cut off, so it was just made to look pretty. Cool. What's the volume of that donut? And so now, yes, volume is going to be a 2 pi integral of x times top minus bottom. Well, the top is simple because it's the function itself, and the bottom is a 0. No squaring. Yeah, I know it was already squared here. I'm saying there's no squaring of the top minus the bottom. They're just as they are, okay? And there's always just a plain old x here. Just throw an x in there. In Cal 2, we get a lot more complicated than this, so don't get too freaked out. That's a whole other class, technically, kind of. So you'll be doing that later. In the meantime, we've got this right here, and so how am I going to accomplish this? Well, we got an x. We got another x. Let's pull the 7 out. At least we got that much. So x squared, and then we got x squared minus 2x plus 1. And then, yes, I'm going to distribute that. And so we technically have x to the fourth minus 2x cubed plus x squared. And so that's x to the fifth over 5. 2x to the fourth over 4. X cubed over 3. From 0 to 1. Plugging in the 0, everything goes away. Plugging in the 1, we get a lot of fractions. 1/5, 1/2, 1/3. Blah, blah, calculator. Skipping ahead here. We got 7 pi over 15. Yes. They have a different way of using this formula, and I don't even want to show it to you, so I'm not going to do it. There you go. Yay. 63012. We got y is equal to 3e to the next squared. Sorry, my computer's glitching out here, and so if you like see me pause or hear it like spasm, I am very sorry about that. It's just my computer just freaking out on me. Okay, so I've got all the stuff here, and what's the picture going to look like? I wish I could draw my axes a little bit better. This is actually a bell curve, and so it's going to do something like that. But we're only concerned about this first area because of stuff like that. X equals 1, somewhere right there. It's actually at the inflection point, and so where it's starting to change from concave down to concave up, that's your 1. Just kind of little small feature for you to understand for the future. Kind of cool there. And so now we're going to find the volume of this as we revolve it around the y-axis. Now, as I revolve it around that, what's the shape going to look like? Well, it's going to look like a bell curve hill that's cut off. And so, actually, I'm going to do this. It's kind of like a bell. Well, because it's an inflection point, it should technically be like this. Something like that. And then it'll be a straight cylinder down. And then just a plain old cylinder at the bottom. There you go. Cool shapes. Looks like a candle, right? Like flame. Yeah, right. That's what it looks like, huh? So, volume is equal to 2 pi times the integral of 0 to 1 of x times my top, and then minus my bottom is 0. Well, this is interesting. The 3 can come out. That makes it simple there. And so then we actually have x e to the negative x squared, which is a classic integral. You need u substitution. And so my dx is equal to du over negative 2x. And so we got x times e to the u du over negative 2x. Your x's cancel. Your negative 2 comes to the front. You get a negative 3 pi integral of e to the u du, which is, you've guessed it, e to the u. And I'll be integrating here in just a second, but plugging my limits, but I need to plug back in my x's, 0 to 1. Each one of these will probably be important to some degree, so be careful. It's not going to cancel anything, so that's e to the negative 1. And you plug in a 0, you get e to the 0, makes a 1. It's like just times 1. 2 negatives make a positive, and so this is 3 pi times 1 minus e to the negative 1. Yup, that's the answer. Kaboom! So, not too bad in the end. 63023. Here's another one. I got y equals the square root of 4x. I've got y is equal to x squared over 4. And they say look in only the first quadrant, and we're going to be revolving around the y-axis. So if you notice that these actually have some kind of symmetry involved with one another, and so I think they're colliding here at 4. And we're going to revolve it around this axis. The picture's a little weird, but it's okay, I guess. I need to be able to find... Oh, how do I know it's 4? Sorry. I'm going to set them equal to one another. And so... I think I'm going to move this 4 over here. Nah. You know what? Yeah, I'm going to move the 4 over there. Yeah. Okay, so I got 4 square root of 4 square root of x equals x squared. And I'm going to divide by the square root of x here to make that 3 halves. Well, it just so happens that this is also 3 halves. And so x is equal to 4. So there, that's how I got my 4. Okay, great. Sorry, I was looking at my notes and I just saw the 4 and I was like, oh, it's 4. Well, I had to find it. So I found my 4. Great. Well, you can see I got a top and I got a bottom. And my top is actually this guy and my bottom's this guy. If you mess it up, just change it from a negative to a positive answer and you're done. So volume, here we go, is 2 pi integral from 0 to 4 of x times top minus bottom. Okay. And so I got the square root of 4 times x to the 3 halves, and then I've got x cubed over 4. And I'm going to add 1 to the power. Divide by the new power. Add 1 to the power. Divide by the new power. Actually, it's a 16, sorry. From 0 to 4. Of course, the 0 is going to cancel everything. Square root of 4 is just a 2, isn't it? Is that what they gave me? Okay, well, I guess they're half cheating a little bit. Or the randomization's just strange. Yeah, what's the square root of 4? It's just a 2. And it's going to combine with this 2 here to make a 4/5. I was just so fixed on keeping it like what they had that I didn't even think of just saying, isn't that just a 2? So, yeah, it happens. Actually, I'm looking back and forth just a second here. Yeah, this is great. Okay, plug in the 4. The 0, of course, will make everything go away. I'm not going to go through all those specifics. 96 pi over 5, and there you go. Cool. Sometimes I just wonder, like, is this ever going to end? xy is equal to 3. X equals 0. Y equals 3. Y equals 5. About the x-axis. Huh? I thought that we were doing about the y-axis in this section. Just draw it. What does this shape even look like? Well, if you divide by x on both sides, you get y equals 3 over x. That's a rational function, and you should be able to draw this, no problem. So from y equals 3 to y equals 5, and now I'm having problems. And yes, it's about this x-axis. Good luck. Yep, guess what? You're going to have 2 different integrals. You have your rectangle here, and then you got the top and bottom here of disk method. So what they're trying to say is that you could instead go not x and y, but y and x. This skill that I'm doing here is very important. You need to be able to train yourself to do this. Now, it's not the most critical thing in the whole wide world if you're not the best at switching this stuff. I mean, I get it. It's not easy, but you should be training yourself and not avoiding it. That's the key. Don't avoid this stuff. train yourself on it. Like, I'm saying that because I've had a lot of folks in my other classes say, well, I can't ever see it. I don't know how you're doing that. So, I mean, honestly, I just try to be nice with them, but I mean, I'm going to be nice with you too. I mean, that's fine. I understand it's not a problem, but it is important for you to eventually be able to do that skill so that it's easier to do these problems. Could you do this with disk method right here? Disk method, yes. You'd have your one top and bottom. You have another top and bottom. Integral plus integral, and I'll see you in about 15 minutes. You don't want that. You want to be able to be, like, I guess, smart about it and see if there's another way. So I changed it. And so now my volume is going to be a shell method instead. 2 pi integral from 3 to 5 of, it's not x here. I would normally just put an x, but we're using different variables. Just put a plain old y. And then I need to put stuff in terms of y here, so this is actually not acceptable here. I need to divide by y on both sides to get x equals. Because again, I'm using y's and stuff. dy, y, everything's got to be a y. So you must put y's in there. Thankfully, this goes away, and these actually cancel, leaving you with a very simple integral. Don't overdo it, though, here, okay? Oop, that's a 3 to a 5. So we got 6 pi y. Plug them in, 12 pi is your answer. Okay, cool. Let's do another one. 63017. I've got y is equal to x to the 3 halves. Y is equal to 8. X is equal to 0. X axis. Now, I don't know why, but I felt the need to get this wrong 5 times and 3 times, 5 times, whatever it is, the settings. And I got 192 pi, and that's my answer there. I don't know why I put that there, but that is still a legit method of trying to understand these problems. Say you're on the homework, and you can go and ask me a question. Eventually, I'll get back to you, of course. But in the meantime, why don't you just get it wrong? See what they have. What's their answer? What's their answer format? Did they give any hints? Is there anything else available to you? Can you work backwards, maybe? There's a lot of options to go and try this on your own. So, yes, ask me questions. That's totally fine. I'm just literally not standing right next to you every minute of the day. So that's the hiccup in that plan. Be able to start working with your own resources in a way. Okay. And so let me start graphing this thing. This 3 half stuff is going to end up looking parabola-ish. So anything with a higher power than 1 is going to end up going up over time. Kind of like a parabola. And so then we got a y equals 8. And x equals 0. And so this stuff here, and they say go about the x-axis. I'm telling you straight up, this is disk method. That's right. We got a top, we got a bottom, and we're going from something to something. We're done. Now, I think this is a 2, and the reason why is because I'm setting these equal to one another, and when you do 2/3 with the 8, I believe it's going to be a... Oh, it's not 2, it's 4? Okay, hold up. Hold on. Yeah, it's not a 2, it's a 4, apparently. Let me... See, this is me assuming again, right? Okay, hold on. 8 power, 2 divided by 3, close, and I got 4 indeed. Okay, so I just verifying it with you that it's not a 2, it's a 4. Okay. Cool. So then disk method says my volume is equal to a plain pi, 0 to 4, of top squared minus bottom squared. This is top, this is bottom, 8 squared. X to the 3 halves is my bottom, all squared, dx. So why is this in the shell method section? Well, because they're wanting you to branch out. They're wanting you to be able to use both tools depending on the situation. So like you have you have a screwdriver with a Phillips head, the cross section, and then you got a screwdriver with like a standard flat head, which is just like a straight bar, and you have two different screwdrivers for two different kinds of screws. And so, could you use a flat head on a Phillips? Kinda. Can you use a Phillips on a flat head? No, not really. It just kind of depends on the screw, really. So you have two different methods. Today, disc method is going to be a lot better. So do that. Integrate. The 0, of course, is going to make everything go away. You plug in the 4, and you're going to get a value. And, oh, wow, it's 192 pi. So that was super nifty. 1, 2, 3 problems left, and the last one's an easy one. The next two were terrible. So, 63018. So I've got x is equal to a negative 3y squared plus 15y minus 12. They say x also equals 0, and you're going to be revolving around the x-axis. For one thing, this is all wonkadoodle, and so I would rather pull out a negative 3, leaving me with at least something with some more semblance, I guess you can say. I could factor this down to a negative 4 and a negative 1. Yes. And so I can actually graph this thing. It's going to be an upside-down parabola, and it's going to be touching at y equals 1, y equals 4, 4, and 1. Upside-down parabola, so normally it would actually look like this guy. Cool. And with 0 and about the x-axis. I have no clue how I would do this with disc method. I mean, yes, I do. You would cut it in half, symmetry, and then you'd have a top and a bottom, and you find whatever this, da 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 da. No. So this is my x and my y. It's already hard enough to draw it like this, right? Do you know how to draw a parabola sideways that's upside down? Why don't we just draw it like this? So then I got 1, 2, 3, 4 upside down parabola. And there we go. Oh, wow. It's a shell method. So I'm going from 1 to 4. X. Oh, it's not X. It's a Y. And then I got my top and my bottom. And obviously you know my top. And there's my bottom. Top. Bottom. dy. The negative 3 can come out. And then I have no better option than to refoil that stuff and then distribute. And then integrate. Is the silence weird? Is it weird to hear the silence? Sorry. So plugging in the 4, we get stuff. Plugging into 1, you get a lot of fractions. And yeah, in my notes, a lot of times I actually do the work by hand and all that. Here, no. In my notes, I just cut to the end because that's calculator. I know you can do it eventually. 63019. So I've got x is equal to 1 plus y minus 4 all squared. X equals 2. X axis. If you want to draw this normally, that's fine. You can see I have a center. If you're not noticing that, I'm actually shifted up by 1 and over to the right by 4. But again, this is going to be a y and an x like that because I don't know how to draw that parabola sideways. I mean, it's hard enough for me to see that it was shifted at all. How am I expected to also know how to draw the inverse of it? Then don't. X, y. Oops, I meant y and x. My idea, my thing is that draw what makes sense to you. x equals 2. Well, that's actually right there, isn't it? Wow. And we're going to revolve it around the x-axis. So I did not even draw it like I normally would. I drew it immediately the way I should. You don't need to keep flipping things. Just draw like you normally would. And you remember your transformations, don't you? So, sorry. That was just a small little, bloom. And so this is going to be a shell method. As far as I can see, I got a top and a bottom. Where are they touching, though? Where are we going here? And I got to set them equal to one another in order to do that. Square root both sides. The square root of 1 is a 1. But whenever I do that, I have to have plus and minus, I guess. So I got 4 plus or minus 1, and so that's going to be a 3 and a 5. All right, we can do that. So here we go. Volume is 2 pi integral 3 to 5 of y, just a plain old y, and then we got my top and my bottom. My top is a 2. My bottom is all this other stuff. Okay. I guess I could just distribute that, and I would get a 1 negative y minus 4 all squared. Let me check my notes. Yep, that's what I expected. So I distribute this, but in order to do that correctly, what you really need to do is FOIL this thing out. Yes. So now you can distribute that y there. It's all very hard, isn't it? Oh, I know. I'm doing it too. Combine like terms, I guess you can combine those. It's not going to hurt anything for sure. And we're finally going from, again, 3 to 5. Add 1 to the power. Divide by the new power. I mean, this is not hard. It just is so long. And again, at this point, I just said, you know what? Calculator. And I'm looking at it back and forth, and I see identically the same thing. So I must have done it right. Or I had it wrong in the notes, but that's highly unlikely because I was looking at the answers. So I actually do this work beforehand, of course. I have to. And that way I can see if I'm doing it right or wrong. Last problem. Very, very fast. And let's just pause for a second here. You know, I draw a lot of pictures, and I don't think I've been drawing every picture up here. I mean, you can draw... What is this going to look like here? Let's just draw the shape, because it's fun to see. It's actually kind of like this, but it's got like a little parabola hump all right here. Oh, you know what? It's those cakes. It's those upside-down, like, bundt cake things, right? I don't know what to call them. They're the pans that have, like, on the bottom, and the shape... make it look like a fruit cake or something, and then you flip it over, upside down cake, something like that. I don't know. There's a cake pan like that. There you go. There's my cake pan. And so, but I'm doing this in particular because I want to show that the pictures sometimes in 3D mean a lot more than other times. So I'm happy to have done that. That didn't really help me on this problem. But what about this one? What about this problem right here? Let's be more honest about it. What is this shape right here? Be careful. It's a circle. And it's been shifted. It's been shifted up by 1. It has a radius of 1. So it goes from 2 to 0. And I've got a circle. That's the best circle I can get right now. Okay. And they want to revolve it around the y-axis. Very interesting. Well, let's just get rid of this side for a little bit, and let's just look right here. And that's just for my own sake, okay? So I'm going to take this side, I'm going to wrap it around, And yeah, guess what? You just made a sphere. Yep, you made a sphere. Isn't that so cool? Knowing that it is a sphere, we have a formula for that. 4/3 pi r cubed. 4/3 pi r cubed. Yeah, Wikipedia that one. Oh, I know. What's your radius? Is 1 distance everywhere. 4 pi over 3. And you're done. It pays off to know these shapes because I don't want to have to do that. Nobody wants to have to do that. Okay. That's all I got. So, again, you can look over my Cal2 version. I think it's going to be significantly harder, but at least it's more stuff. And you can always ask me questions. Thank you very much. Have a great day.